Hello class 12. Now I continue with my second video with special integrals. Just before this today, I explained to you how to do special integrals where the denominator is a quadratic function but the numerator had only constants, right? So here are some examples where the denominator is a quadratic function but the numerator is a function of x. So where the degree of the function in the numerator is less or more than that of the denominator. So now as you're copying, I will just like to give an advice to all of you as being the senior teacher that as you enter, now since the board exams for in some places has started, so when you answer the examination, nervousness should not set in. Okay? And that is why we pray God to give you strength to remember what you have studied and not to have that nervousness set into you, right? So when you're reading a question and you get the question paper, take the choice, right? Where you have choice. The questions you read where you have choice in your reading time and make ticks and just tick the sums which you are choosing. And naturally you will choose the questions which you know the best, right? So as you're choosing, suppose out of 6 you have to answer 6 and you answered 5, you're very confident. That confidence builds in your strength, you know, and it puts in all hormones back to your, and it accelerates your memory, right? And then you go back, then you have time, so you have decided and you're so happy that I know so many of them. And maybe 1 or 2 I'm a little doubtful, doesn't matter. Then you come to the compulsory section and keep reading it. So, and then you begin your question paper as per the schedule, when the writing time begins, right? But when you read the compulsory questions and you see that question number 1 I do not know, 3 I do not know, 4 I am doubtful, you know that nervousness sets in. Don't allow nervousness to set in you. Because even however well prepared you are, you know, you forget. You suddenly forget the formula. You suddenly write 3 plus 2 as 6. You're multiplying. So don't allow that, right? That is why we pray God that I do not become nervous. I should be in my best when I'm answering the paper. So all the best children, those who are answering. So I think you must have copied the questions. Now let's see this. Now see in the numerator first. All have a function of x in the numerator. If you see the first one, number 1, number 2, then you have number 4 and number 5. So question number 1, question number 2 and number 4 and number 5, the degree of numerator is less than the degree of the denominator. So there is no long division. You don't have to divide the numerator by the denominator. So but as soon as you see a quadratic, don't think it is special integrals. Never think it is special integrals, children. Because first, that is why you have to identify, recognize, be intelligent in tackling the sum. And when does the intelligence set in, children? Only when you do a lot of practice in maths. Okay? So here first one is, it is simply 5 minus x by x minus 5 whole square. It's a perfect square and the numerator and denominator are the same. So then you write this as minus of x minus 5 and x minus 5 whole square. So this ultimately becomes 1 by x minus 5. Again I read it, right? The question was 5 minus x by x square minus 10x plus 25. I am not going to do, the formula, the numerator is L times the denominator plus M times the differentiation of the denominator. So these are all the people who by heart the techniques, right? So we need some kind of presence of mind and intelligence to do it in a short way. So here you see that this is a perfect square of x minus 5 whole square and this was 5 minus x, which I can write as minus of x minus 5. It gets cut and simply the answer becomes minus ln of x minus 5 plus c. That's all, right? What is integration of 1 by x? Log x base e or ln x. What is integration of 1 by ax plus b to the power of 1? Ln of ax plus b, the whole thing divided by a means 1 by a times ln of ax plus or minus b, right? So similarly is ln of. And if you keep it like this, suppose you write this as this sum minus you got this, I can write this part as I want to remove the negativity in me. So I want to remove the negative sign. I can write this as 1 by 5 minus x. So I can also write this as 1 by this. Ultimately this becomes 1 by 5 minus. This is safer. I'll tell you why. This is safer. Not changing. Let it be as it is, and you write ln of x minus 5 and minus sign in front of it plus c. Because when you write it as, if you multiply here and write as 5 minus x dx, you have a tendency, majority students will write ln of 5 minus x plus c. Children, be very careful, that's wrong, because this is ln of 5 minus x plus c and divide by 1. Differentiation of minus x is minus 1. And majority students forget this. Remember that. So that is the risk factor in making it like this. But you must remember that, okay? So when you have 1 by b minus ax or 1 by b minus x, it is ln of b minus x divided by minus 1, okay? So first sum is over. What about the second sum? You will see that most of the sums I make it myself, children, because you are my books. You are my books. And therefore, your books I read, your mind books, and then I make my questions, right? So here this one, what is this? Again, you can do the technical way, writing the numerator as L times the denominator plus M times D dash differentiation of denominator, right? But I will write this as, this sum is simply x plus 2, saving time, perfect square x plus 3 whole square dx, x minus. Okay, and we have done, if you have seen my video where of linear functions, integration of linear functions, especially when they are in the denominator, I did teach you, children. Just go back to my integration 12th. Okay, so here, what do? Both are linear. So I'll take x minus 3 as t. Right? So let us continue the sum. What was the sum? X plus 2, copy it down, by x square minus 6x plus 9. So instead of doing the traditional way, which you learned it, so I wrote it as x plus 2 and this is the perfect square. So I take x minus 3 as t. So it's also a revision of this type of sums which are given. Right? So you have, in this sum, you are taking x minus 3 as t. So dx is dt. So you are writing this one, this from here. We go back, we are writing this as, and what is x? T plus 3. So I'm putting x as t plus 3 and the plus 2 and divided by t square. And you know how to do this. And dx becomes dt. You cannot have t and dx. That is why we are differentiating to replace dx as dt. Function of t, dt. Function of theta, d theta. Function of x, dx. So here you have t plus 5 by t square, which becomes integration of t plus 5 by t square dt. So integration of 1 by t, if I separate it, and integration of 5 by t square dt. So this same sum, I'll repeat and write it again. So after substitution I get this. So I get integration of 1 by t plus 5 by t square. And you know what is the integration of both? Right? This is ln t, and this is 5. 1 by t square is minus 1 by t. So minus 5 by t plus c. And now you put t as, what was it t? X minus 3. So put in this place t as x minus 3. So ln of x minus 3 minus 5 divided by x minus 3 plus c. Because I'm explaining, otherwise it becomes very, very short. Okay, now that is sum number 2. What about sum number, okay, before that we'll do sum number 4 and 5. Before I touch upon same powers. When the degree of numerator is same as degree of denominator, or degree of numerator is greater than degree of denominator, we'll do that because we have to do division. The others we don't have to do division because the degree of numerator is less than the degree of denominator. This one, how do you do it? So here, this one, suppose you are given 3x plus 2. Please see, children, x square plus 9. Okay, sum number 4. So what do? You just separate them. 3x plus divided by x square plus 9 and 2 by x square plus 9. Okay, dx. I've separated them. Now here, how do you do this? There's x method. So this is not tan inverse x by 3 children because there's an x. So this is substitution. Taking x square plus 9 as t, and this is tan inverse. This is 1 by a tan inverse x by a, where my a is square root of 9. That is tan inverse because there's a number here. And here there's x. So therefore it is x square's differentiation of x square is x. So with whatever constant. So this one, okay. So sum number 3, this one. We are doing sum number 4. So here 3 out. This becomes dt. You are taking x square plus 9 as t. So dx becomes dt by 2. And therefore you have x dx becomes dt by 2. So this becomes simply 3 by 1 by t. Again I repeat, so you know the substitution, that's why I'm not going to do it detail. This you have taken t, so when you have taken x square plus 9 as t, x square plus 9 as t, 2x dx is dt. So what is my x dx? dt by 2. So dt by 2 comes back and therefore. So straight away what is the answer? ln of t, 3 by 2 ln of t, and what is my t? That is this. So coming to this one, 4th and 5th, okay. So this sum, this becomes this is this part, and this is a 2 here, 1 by 3 tan x by 3. For this substitution I get this, where I am taking x square plus 9 as t. You all must be knowing this, how to do. And then finally you get 3 by 2 ln of x square plus 9, because t was x square plus 9, and plus 2 by 3 tan inverse x by 3. So separation. So when you have ax plus b divided by x square plus c square. So ax by x square plus c square, b by x square plus c square. So the second one becomes tan inverse directly. First one is substitution. Because x square's differentiation is x, which gets cut in the numerator. So you have, then it comes to this format. Then we had, so now all these were, the degree was less than the numerator. The degree of numerator was less than the degree of denominator. Okay, so now we are going to see the degree of, I gave you x square plus 3 by x square plus 9. Now the degree is same. So we do long division. When we divide, we get quotient as 1 and remainder as 6. So remainder by this. So this becomes the sum after we divide. After we divide this by this, I get quotient as 1 and remainder as minus 6. So remainder by divisor I have to write. You divide and you can check. But short method, what I do is, when the power is same, okay, and the coefficient of x square is same, I just add 9 and subtract 9. Because I want x square plus 9. You know, x square plus 9. I have a x square plus 9 and a minus 9. So x square plus 9 by x square plus 9 becomes 1, and 9 minus 9 plus 3 becomes minus 6. So when the degree is same and coefficient of x square is same, like x square plus 4 divided by x square plus 1 is simply 1 by 3 plus x square plus 1. Because x square plus 4 I can write as x square plus 1 plus 3. What I am saying is this. If you are like this, so why do you divide? You can directly do, this is x square plus 1 plus 3. So 1 plus 3 by x square. Same thing you will get when you divide. So after that you get 1 dx is x, and this is a constant, and this is 1 by a tan inverse x by 3. Yes, because a is 9, a square is 9, so a is 3 directly. So this is short. Power is same, degree is same, right? The next one is, the next one which I gave you was, the other one which I gave you was, suppose you have x plus 2 and x square plus 4x minus, say 7, whatever it is, right? Or plus 7. Right, so here when you have this, then this is not again taking numerator and writing L times denominator plus M times differentiation of denominator. and that is the numerator. X plus 2 equals L times denominator, whatever. So not taking that way, or taking numerator as a constant plus some multiple of the differentiation of denominator, right? Instead of that, you can write this as, this is directly substitution, children, because when you have x square plus 4x plus 7 as t, you get 2x plus 4 dx is dt. So x plus 2 dx is dt by 2, taking 2 common. Twice x plus 2 brackets dx. So what have you got? X plus 2 dx is simply dt by 2. And this is my t. So answer is half log t. So half ln of t, that is half ln of x square plus 4x plus 7 plus c. Yes, so quadratic, the differential is there in the numerator, or some multiple of the differential is there. So even when you're doing numerator is L times d dash plus m, so here you're going to get m as 0, right? Same thing, it is the same. So now this is direct differentiation. So I told you the separate. Now see this sum. The power of the degree of numerator is greater than the degree of the denominator. So long division, I told you, same or greater. Now you have this. Am I right? So in this, you're doing long division. So what are you getting after long division? So this sum, integration of x cube plus 3x plus 1 divided by x square minus, because the degree is, so when you divide, quotient you're getting x plus 4 and remainder you're getting 13x minus 23 by the divisor x square minus 4x plus 6. You're getting this, am I right? So you can integrate this, easy integration. Integration of this is x square by 2 and this is plus 4x, and this you already done. I told you a quadratic expression is there in the denominator. The numerator can only be a number, can be a number and a function of an x, or only x and a number, which I showed you by illustration, the different examples. See? Now finally after division. So why will they give you formulas for all polynomials, numerator any polynomial by quadratic? No. Okay. So this is ultimately the simplest form, the maximum terms in the numerator you can have when the degree has to be less than a quadratic expression. So now this is very easy. This is x square by 2. This is 4x. Now this I told you which method. Okay. So this method is you take now quadratic. So you will integrate this. I will tell you, I'll come to that now. Okay. Then integrate. Separation you can't do because you have to keep this like this, and we'll do it. How do you do in the exam? So this one, integration of 13x minus 23 x square minus 4x plus 6 dx. And you have done it as a formula. It will be like you have anything of the form ax plus b, and you have some like a quadratic expression px square plus qx plus r. Okay. And they say take ax plus b as L times denominator differentiation plus a constant. Yes, and then you separate it, right? So I will tell you, without doing this, how do you do very fast? When you have a linear by a quadratic which cannot be cancelled, which cannot be factorized and get cancelled, it is not a perfect square, or it is not, the numerator is not the direct differentiation of the denominator. I told you, if it's x plus 2 and you have x square plus 4x plus 11, you know direct integrate substitution of the denominator, the numerator gets cancelled, right? So therefore, if it is ax plus b divided by this, and nothing can be simplified, as I given you a variety of examples, then you do this method in the book as it says. But let me do a simple method without. So suppose you have like 3x plus 2 and you integrate by x square plus say 6x plus 11, something like that. Okay. Now you know it can't be factorized, and if you do 2x plus 3, so it's not the differentiation, you got 3x plus 2, right? If this was 2x plus 3, fine. right? So here what you do, I'll tell you easy method. Separate and put the number out. Okay, keep the x simple, 11 dx, and separate the 2 which is a constant out. The constants you put out. So you have done just in my previous video, completing squares. This becomes x plus 3 whole square plus 2. So you know how to do it, right? That becomes tan inverse. So this simply becomes this becomes 2 dx, just in the previous example. So I'm not going to again explain to you. This will become a perfect square plus. So this is 1 by root 2 tan inverse x plus 3 by root 2. So this one you directly know it's 1 by root 2 tan inverse the linear part by root 2. That's, you know. Now what about this? Let us go to this, the first integral. So this is my first integral, this is my second integral. Second integral, there's a number in the quadratic. In my just this video before this, I had explained how to do this. So you can refer to that, those who have not seen it. Okay. So here, what do? The same thing. So basically, you are not separating in the book method. The book method says take 3x plus 2 as a constant plus the some constant, that means L times differentiation of this plus m, and you find L and m and separate it. I am doing that only in a short method. By separating I got this. Now you don't have to even sometimes do this. So I'm just showing you this. You don't have to do it. Okay. So you don't have to do this. Now let's see this. Okay. Now in this you just keep this as it. I just showed you how to do it. So just before I wind up, this one you will write what is differentiation of this. What is differentiation of x square plus 6x plus 11? Differentiation of denominator d dx, which is 2x plus 6. 2x plus 6, right? So what you do, just write 2 and divide by 2. So you got 2x plus 6 I want. Plus 6 and a minus 6. Right? Now separate it. Again separate this. So 3 by 2, 2x plus 6 by x square plus 6x plus 11. And then minus 3 by 2 times 6. There's a 3 by 2 children. 3 by 2 times minus 6 is minus 9. 2 3s are 6. So minus 9 times. Okay. Dx by x square plus 6x plus 11. And plus 2 times dx by x square plus 6x plus 11. That's why don't integrate this first, because you get a like term here. Here you got a like term, minus 9 times a variable, and you have plus 2 times the variable, right? Minus 9 plus 2 is minus 7. And just now we did integration of this. Okay, just now we did x plus 3 whole square plus you have x plus 3 whole square plus 2. Just now I did this, and this, you know, differentiation. This is your t, this is your dt, and 3 by 2. So integration of this becomes 3 by 2 ln of t, and this becomes minus 7, 1 by a. This is x plus 3 whole square. So that is root 2 tan inverse x plus 3 by root 2. I just now did this, children. This is x plus 3 whole square plus 2. So tan inverse x plus 3 by root 2 and 1 by a root 2 and minus 7. And this ln t, what will you substitute for t? X square plus ln of x square plus 6x minus plus 11 and 3 by 2 and minus this answer. So this answer. Okay. Again I repeat, which is the formula method. I am taking this, I am separating the two. That is 3x and a 2. Right. So I am separating the two, 3x. So I take the constant out. So this one. So I am separating the two. So 3 times, take the constant also out, x square plus 6x plus 11 plus 2 dx x square plus 6x plus 11. This you know the integration, but don't do it immediately. Okay. Just take this and find the differentiation. So differentiation of this d dx of x square plus 6x plus 11 is simply 2x plus 3. So I want a 2x. Put a 2 and divide by 2. So if you simplify, I got same answer. Plus 6. Okay, you can also take x plus 3 also, no problem. You can take x plus 3 and I don't need the 2. I don't need the 2. I'm just telling you the other sums if you got 2x plus 5. So keep it like that. So you can also take x plus 3. So 2x plus 6 and a minus 6. So I get difference here. Now you separate this 2x plus 6 with this. So 3 by 2, the differential part is this, divided by x square plus 6x plus 11. And this 3 by 2 into minus 6 is minus 9. And minus 9 times this. And so you get minus 7 by dx by x square plus 6x plus 11. Okay. So I'm just repeating it because I've done it. If you copied it. This was 3 by 2 minus 6. This you are separating and this you are separating. This is this. And here you get minus 9 times this. And this plus 2 times dx by x square plus 6x plus 11. Right? And then these two are like terms. So minus 7 dx by. And this now you make it a perfect square. Plus 2. Finished? Because there is a constant in the numerator. Right? And this is substitution. This is t and this is dt. That's all. So this you substitute as t. Differentiation gets cancelled. So that is 2x plus 6 dx is your dt. So dt by t, ln of t, substitute t as x square plus 6x plus 11. So final answer is 3 by 2 ln of x square plus 6x plus 11 minus 7 by root 2 tan inverse x plus 3 by root 2. Is it clear? So that's how you see the different types of sums in special integrals. Same follows in this. Only in this, if you get a minus 2, that becomes the formula of ln. When you have dx by x square minus a square with a number, it's 1 by 2 ln of x minus a by x plus a. And if you have like dx by a quadratic, which you complete a perfect square, x plus minus b whole square minus a square, not plus a square, that's 1 by 2a ln of the linear part minus b, minus a, and the linear part plus b. What I mean to say is, if you are having a quadratic, you complete a square, constant on the top, constant, and you complete a square x plus or minus b whole square minus a square. This formula is 1 by 2a ln of the linear part minus a, the linear part plus a. That's all. The formula has changed. That's all. But the rule which I taught you, completing a square, for denominator, only if the numerator is a number, right? And if it's function of x, I have taught you how to do the various ones. Thank you, children. Hope you liked it. And please, if you need any queries, just message me. Bye. Okay? All the best.